हेलो स्टूडेंट्स, हमारे यूट्यूब चैनल एक्सपीरियंस ट्यूटर में आपका स्वागत है। आज हम लोग डिस्कस करेंगे क्लास 12 बोर्ड्स का फिजिक्स का इंपॉर्टेंट क्वेश्चंस इन 5 मिनट्स। आज का क्वेश्चन है क्वेश्चन नंबर 7। आज का डिस्कशन प्रारंभ करने से पहले आप लोगों से निवेदन है, अगर आप हमारे यूट्यूब चैनल को अब तक सब्सक्राइब नहीं किया तो प्लीज सब्सक्राइब आवर चैनल और हमारे इस वीडियो को लाइक और शेयर जरूर कीजिए और बेल आइकन के नोटिफिकेशन को जरूर ऑन कर लें। इससे आपको हमेशा नोटिफिकेशन मिलती रहेगी जब भी कोई वीडियो हम अपने चैनल पे अपलोड करेंगे। चलिए आज का लेसन शुरू करते हैं। तो क्वेश्चन नंबर 11 है, यूजिंग गॉस लॉ derive the expression for electric field at a point outside and second inside the uniformly charged thin spherical cell। तो इसमें सबसे पहले हम क्या लेंगे, there let there be a thin spherical cell whose center is O and radius R। So for your sake we have drawn the picture. Let us see the picture. So if you can see the picture, there is a spherical cell. Uh, so you can see half of the picture, but everything is clear, so that you can see the text as well as the picture. So uh, there is a spherical cell with center O, and this radius is R, capital R, and this radius is small r. Okay. So this is now let sigma be the uniform charge, surface charge density, and q be the total charge on it. So q be the total charge and sigma is the surface charge density. The charge distribution on the spherical symmetric, so charge density is symmetric. We have to find the electric field at a point outside the cell where r is greater than, small r is greater than capital R. Okay, this is the first equation we have to find it out. Let us see how to solve it. We have to find the electric field at a point P at a distance r outside the cell. Let us consider a Gaussian surface in the form of a sphere of radius small r, where small r is far greater than capital R. तो ये जो क्वेश्चन में दिया है उसी को हमने in our own words we have written what is given to us. Now by symmetry, the electric field acts radically towards and has a normal component at all points on the Gaussian surface. Therefore, electric flux phi is equal to, what is phi? Phi is equal to E into A, electric field intensity into area. So here E is, we'll keep E as E, and surface area of the sphere we know it is 4 pi r square. So this is equation 1. A is the area of the Gaussian surface, and in our case it is a sphere, so surface area of a sphere is 4 pi r square. So this is all equation 1. According to Gauss law, so what according to Gauss law we can say that phi is equal to q upon epsilon naught. So what is the value of q? Q is the total charge, so surface charge density is sigma, area is A, so q is equal to sigma into A upon epsilon naught. So sigma will leave it as it is, and area, surface area of the sphere is 4 pi r square upon sigma upon epsilon naught. This is equation number 2. From equation 1 and 2, what we got? We got E into 4 pi r square is equal to, so both are the value of phi. This is also phi, E into 4 pi r square, and this is also phi, which is sigma into 4 pi r square upon epsilon naught. So we can equate phi in both the sides. So we got E into 4 pi r square, sigma into 4 pi r capital R square upon epsilon naught. Now we'll find an equation for E. Therefore E is equal to, just we'll keep E in the left hand side and move 4 pi r square in the right hand side in the denominator, and which will get cancelled, and we'll get sigma r square capital R square upon epsilon naught rq. So after solving it we get uh, q upon 4 pi epsilon naught upon r square. Sigma instead of sigma we can write q upon 4 pi 4 pi r square, and r square gets cancelled, and upon solving we got E is equal to Q 4 pi epsilon naught r square. So first part of this equation is solved. In the next part, inside the spherical cell, so in this case r is much smaller than capital R, and the Gaussian surface drawn inside the cell does not enclose any charge. So let us see the image. So this is the image. Now the spherical sphere is inside, and small r is far smaller than capital R. Surface charge density is sigma as before, and Gaussian surface is the dotted one inside the sphere. So we can write, hence according to Gauss theorem, phi is equal to q by epsilon naught. Since the charge is enclosed, so this value is 0 because q is 0. Okay. Now we can write, instead of phi, we can write E into 4 pi r square, which is equal to 0 upon epsilon naught, and E is equal to 0. So inside the sphere, it will be 0. Hope you like this video. Before we end our class, we request you to subscribe our channel and like and share this video. आपका आज का दिन शुभ हो। इस शुभकामना के साथ हम लोग आज का क्लास यहीं समाप्त करते हैं। थैंक यू वेरी मच।